Hello, welcome to Maths with EJD. This is the second lesson on matrices. In the first lesson, we considered introduction to matrices. So today we go ahead to look at the types of matrices. And straight to the point, we have first of all, row matrix. And a row matrix is a matrix with a single row and multiple columns. A single row and multiple columns. The examples you see there, 1, 2, 3, one row, 3 columns, ABC, 1 row, 3 columns, and minus 2, 5, 1 row, 2 columns. So the key thing here is that a row matrix has just 1 row. It doesn't matter the number of columns. And then we go ahead to talk about a column matrix. A column matrix on its own part has just a single column and multiple rows. So the first example, we have 1, 2, 3, which is just 1 column, but 3 rows. ABC, 1 column, but 3 rows. Minus 2, 5, that's 1 column, and then 2 rows. So that is a column matrix. Now, collectively, you can call these types of matrices, you can call them vectors. They are called vectors. So if we're considering linear algebra as a whole, we will be talking about vectors, and row and column matrices can be seen as vectors. Okay, let's move on to talk about other types of matrices. The next one will be square matrix, and these are particularly important. In fact, you're going to come across a lot of square matrices as we move on. A square matrix is simply that matrix with an equal number of rows. So equal number of rows and columns. Equal number of rows and columns. So if you have a particular matrix that has the same number of rows as it has columns, then that is a square matrix. Like you see this first example, this is a 2 by 2 matrix, 2 rows, 2 columns, row 1, 1, 2, row 2, 3, 4, column 1, 1, 3, column 2, 2, 4, like that. And then you have a 3 by 3 matrix called B with 3 rows and 3 columns with A, B, C, D, E, F, G, H, I. So that is a square matrix. When the number of rows is equal to the number of columns in the matrix, you say it is a square matrix. Of course, that leads us to the idea of rectangular matrix. A rectangular matrix is a matrix with unequal number of rows and columns. So when the number of rows is not equal to the number of columns, then you can say you have rectangular matrix. So in a sense, you can say that column and row matrices are all rectangular because the number of rows are different from the number of columns. But those ones are special in that they either have just 1 column or just 1 row. So here, a matrix with unequal number of rows and columns, unequal number of rows and columns, then that tells you it's a rectangular matrix. For instance, when you have 2 rows and 3 columns, like you have here, that is a rectangular matrix. When you have 3 rows and 2 columns, that is a rectangular matrix. Okay, let's move on as we talk about some special kinds of matrices. There are still special matrices we are going to consider down the line. So when we get there, we'll talk about it. So, but now let's talk about diagonal matrix. As the name implies, a diagonal matrix is a matrix where all elements outside the main diagonal are 0. Now, for every matrix, there are 2 types of diagonals. Let's imagine we have A11, A12, A21, A22. You see, this is a 2 by 2 matrix, a 2 by 2 square matrix. Now, the main diagonal or principal diagonal is the diagonal containing A11 and A22. So this is the main diagonal. Main. Okay, I guess I should use another color to make it different. Say black. Okay, so this is the main diagonal. Main diagonal. Then this other one is the other diagonal, if you like. So with that, we can say again that a matrix where all elements outside the main diagonal are zero. So so you see the main diagonal here is 3 and 7. Every other element is zero. That is a diagonal matrix. Come here again, the main diagonal, the elements are all the main diagonal has elements 2, 5, and 8. Every other diagonal is zero. Then you say that is a diagonal matrix. And then that takes us to the idea of a unit matrix. A unit matrix is actually a special type of diagonal matrix. At the same time, it's a special type of square matrix. So a unit matrix is a special square matrix where all diagonal elements are 1 and all off diagonal elements are 0. So you can see that all the main diagonal elements in this 2 by 2 matrix are 1. In this 3 by 3, they are also 1. Interestingly, the idea of a unit matrix is just like the number 1 when you talk about normal numbers. And one thing with that is that when you multiply any number with 1, normally you get that number back. In the same way, when you multiply any matrix with a unit matrix, you get that matrix back. For instance, assume that you have a matrix Q. Assume that you have a matrix Q, and then the unit matrix is usually represented using letter I. So if you multiply a matrix Q by matrix I, the unit matrix, or you multiply the unit matrix by Q, you end up getting Q always. It's just like when you multiply a regular number by 1. So the unit matrix plays a role of 1 when it comes to matrices. So, and of course, it only exists for square matrices. You don't have a unit rectangular matrix, for instance. Okay, we move on to talk about uh, another type of matrix, which is the scalar matrix. Interestingly, this is also a kind of diagonal matrix. And this is a type of diagonal matrix where all diagonal elements are the same. All diagonal elements are the same, just like you see here. So when we say diagonal here, we mean the principal diagonal. So if all diagonal elements are the same, then that is a scalar matrix. So take note that for every scalar matrix, it is actually a scalar number multiplied by a unit matrix. So when you have matrix minus 7, 0, 0, minus 7, you discover that it's actually minus 7 multiplied by the unit matrix. Or when you have 3, 0, 0, 0, 3, 0, 0, 0, 3, it's the same thing as 3 multiplied by the 3 by 3 unit matrix. That is scalar matrix. Okay, having said all this, I have a bonus for you. We've been talking about matrices. Can we consider a practical example of matrix? Can you imagine your personal expenses? Maybe you spend majorly on groceries, utilities, and entertainment. And then you do that month in, month out. So let's say maybe this is what you have spent, or you can also make it a kind of budget matrix that, okay, maybe you can make this kind of thing for the whole year, that for this year, this is how I'm going to spend my money. Like on groceries, 1,200 in January, on utilities, that's 800, entertainment, 1,000, and so on and so forth. Whatever unit you're using, maybe dollars or whatever. Now, you see that the rows, so for all the rows now, the months are captured in the rows. So all this, they have months. So the rows represent the months of the year, and then the columns represent your expenses, your should I say expenses now? What you spend on, how do I call it? Should I call it, let me just call it expenditure. Let's call it expenditure. So basically talking about what you spend money on. So such that if I take 600, for instance, then you can say that is so if your expense matrix is E, so $600 or whatever would be your that will be your utility spending in the month of February, So, or better still, since row comes before columns, so you can say that is your expense on your February expense on utilities, something like this. So, so with this, you can say that you can represent your daily life things in form of matrices. Interestingly, you have been doing this all your life as far as you use Microsoft Excel, because of course we can easily put this in an Excel sheet and then we have it. So basically, rows and columns are representing your monthly expenditure categorized into three. Thank you so much for listening. We'll take it further in the next lesson where we consider operations on matrices or so. Thank you for listening.